Assalamu alaikum, dear students. Welcome to the next online class of software engineering. Today, we are going to study the Rational Unified Process (RUP), which is a very important software development framework used in professional environments. Think of Rational Unified Process as a structured way of building software step by step while ensuring quality, proper planning, and successful delivery. So, by the end of this lecture, you would understand how RUP works, its different phases, and how it applies in real world projects. So, now let us start with an introduction to a rational unified process. Students, RUP is not just a method, it is a framework, it's a complete framework that tells us how to organize tasks, assign responsibilities, and manage development effectively. The main purpose of RUP is to ensure that software is developed on time, it stays within budget, and most importantly, it meets the user requirement. So instead of a random coding, RUP, the Rational Unified Process, gives us a disciplined and structured approach. So let us now understand the key characteristics of Rational Unified Process. One of the most important things to understand is that RUP is iterative and incremental. Now, these are two keywords, iterative and incremental. Now, what does that mean? So, instead of building the whole system at once, we build it in small parts. That is what we mean by incremental. The entire system is not built as a single unit, it is built in small parts. So these small parts are referred to as increments, as we have already studied in the incremental model. And then improve it through multiple cycles. The system is built in small parts, and improve it through multiple cycle means that have different iterations of development. So it is incremental because the system is built in smart parts and it is developed in different iterations or multiple cycles. So it also focuses on continuous feedback, early risk handling. If you remember, risk handling was a major part of the spiral model, and flexibility in handling changes. So these are the main characteristics. So as far as the characteristics are concerned, so we have discussed 5 different points. It is an incremental framework in which the system is built in small parts. It is iterative. It focuses on continuous feedback and early risk handling, and it is flexible in handling changes. So this makes RUP very suitable for complex system where requirements may evolve, because in mostly complex systems the requirements are not clear in advance. They evolve with the passage of time as the project progresses. So now, as we have already studied other models, so let us see, or let us try to discuss the relation of RUP with other process models. RUP is not something completely new. It actually combines ideas from other models. Like from waterfall model, it takes that structured and clear phases, which we are going to see in the upcoming slides. From iterative models, as we have just discussed in the characteristics, it takes repeated development cycles. So that is the nature of the iterative model, which we have already studied. And then we have already introduced the agile model, and we characterized it as an adaptive and flexible model. So The adaptability and flexibility of the rational unified process is taken from the agile model. But very important point that RUP is more structured and documentation heavy as compared to agile. We will be studying agile in the upcoming lecture. So in agile model, documentation is not given that much importance. Yes, small documentation is a part of the agile development, but it is not the highest prioritized thing. So although rational unified process takes key characteristics from other models like classic life cycle model or the iterative model or the agile model, it is like flexible and adoptable like agile model, but it is like not that much documentation centric. So as it is written, unlike waterfall, RUP is iterative. Compared to agile, it is more formal. It shares risk handling with spiral but offers clear structure. I have already like talked about the handling of risk in the rational unified process, that this feature is like more of like a spiral model in which risk handling was given high importance. Now there are four different phases of the rational unified process. It is it divides the entire software life cycle into four main phases. These phases are inception, elaboration, construction, and transition. Each phase ends with a milestone, which is like a checkpoint where management decides should we continue or not. So also remember that each phase contains iteration, as you can clearly see in the diagram. It is not a one pass phase like these four phases. The inception, we are going to define the characteristics of these phases in the upcoming slides. But remember that these phases are iterative. They are not one pass phases. I'll be explaining them in the upcoming slides. So after explaining the four phases and after discussing the iterations of or the iterative nature of these phases, let me once again repeat. Each phase has iteration. Work is not done once. It is refined continuously until we reach the goal of the phase. So development is progressive and evolving, not linear like the waterfall model. Now the first phase, which is the inception phase. Inception is the starting point of the project. Here we focus on three to four main things. We focus on defining the scope of the project, understanding of the basic requirements, and checking the feasibility if it is feasible to go ahead with the project. The key question here is this project worth doing? We also identify the core features, estimate the cost and time, and analyze the basic risks. Let us take let us discuss that with the help of an example. The smart banking example. For example, a bank wants to create a mobile application. So what happens in the inception phase? Meetings are held with the stakeholders. The main goal identified is the like secure transaction cost and feasibility are evaluated. So at the end of that inception phase, like the management decides, yes, this project is profitable. Let's proceed. So I have basically summarized. Let me read the slide quickly. That for example, a regional bank decides to develop a next generation mobile application. During inception, the project team holds high level strategy meetings with stakeholders to determine if building the app is technically and financially viable. They identify that the core requirement is, as I mentioned in the start, secure mobile transactions. So by the end of this phase, they have a product vision document and a decision from the board to move forward into elaboration based on the estimated profitability. The second phase is the elaboration. Now, moving to the second phase, which is the elaboration. Now we move to the next phase, which is the most critical phase. Why? Because here we design the system architecture, we address those technical risks which we have identified in the previous phase, and we build a working prototype. We are already familiar with what a prototype is. So the goal is to know, can we actually build this system technically? So by the end of this phase, the architecture becomes stable, major risks are resolved, and not to forget that these activities are performed repeatedly in an iterative manner. So elaboration is arguably the most critical phase. Here the focus shift from vision to technical reality, because now we have to move towards, or we have to think about actually constructing the system. This means that the teams must prove that the architecture can support the requirement. Risks are mitigated by building an executable architecture baseline, a running version of the system that contains the most complex technical components. So by the end of this phase, the architecture is stable and more technical unknowns have been addressed. Now let us understand it with the help of the same banking example. Now the team realizes that connecting with an old banking system is risky. So instead of building the whole app, they focus only on the login and system connection. They build a prototype, and once it works, they gain confidence that yes, the system is like technically feasible. Then we have the next phase, which is the construction phase. Now comes the construction phase where actual development happens. What happens here? There are three main things that happen here. Developers write the code, features are implemented, and testing is continuously done. So the goal over here is to build the complete system. The focus is on quality, performance, and meeting requirements. Exactly the same thing is written over there, that the primary goal is to complete the development of all remaining components and features based on the validated architecture. Validated architecture means the architecture which was developed and approved in the previous phase. Focus shifts to managing resources and controlling the operations to optimize costs, schedules, and software quality through testing. As I have already explained, that the testing is continuously done in the construction phase. And then through unit testing and integrated testing, we ensure that the product release is stable and functional. Now, let's talk about the example which we have been discussing in different phases. Now, in the banking app, now developers build the bill payment, like for example, ATM locators, the statements. Since architecture is already clear, development becomes faster and smoother. So by the end of this phase, after executing multiple iteration, the system is featured complete. So in the construction phase for our banking app, the team is at its peak capacity. Developers are building out the remaining user stories. By user stories means the requirements like bill pay, ATM locator, and monthly statements. So since the architecture was already validated in the elaboration, coding happens rapidly without major technical hurdles, because we have already addressed most of the risk identified and addressed most of the risk previously. So each feature is like unit tested immediately. By the end of this phase, the app is feature complete and ready for the first group of external users. And then we have the next phase, which is the transition phase. Now, this is where the system is delivered to the real users and the testing happens in the real environment. It also includes activities like user training, documentation, and some bug fixing if some bugs are identified in the user environment. So think of this phase as moving from a laboratory to real world. So transition is where the product is deployed to the user community. This phase focuses on finalizing end user documentation, conducting beta test, and fixing minor defects around found by early adopters, means those users which are initially using the system. It also involves packaging, marketing, and configuring the environment for full scale release. So performs the user acceptance test, conducts the beta trials. We have already talked about the alpha testing and beta testing, and pilot releases, finalize user manuals and support materials, and conducting the project post-mortem analysis. Post-mortem means analyzing what happened, why it happened, what were the consequences. If things went well, so those practices should be adopted in the future. If things didn't went well, so obviously we have to rectify those issues. So let us talk about the example of the banking app example. Uh, So the beta launch. So in the banking app, like the app may be released to is maybe released to 500 users first. So obviously there would be some errors. For example, some users find that some buttons are confusing or they are not working. So what we do, we like improve the user interface and apply all the feedback. So the smart app is released to a pilot group of 500 loyal customers or users, and during transition, the team monitors the logs and collects feedback. They discover that, for example, that the bill pay button is confusing for older users. So the design team quickly tweaks the UI based on the real world data. It corrects them, it changes them, updates them. Once the pilot group reports high satisfaction and zero critical bugs, then only then the app is launched for all the users. So, class, to summarize, RUP is a structured, iterative, risk focused. It is best suited for large and complex systems as it ensures better planning, higher quality, and controlled development. Not to forget, just for a quick revision, we have four phases. We have the inception phase at the very start, then we have the elaboration, then we have the construction, and then we have the transition. And each phase itself is iterative, and the multiple iterations are performed inside each phase until we reach the goal of that phase. Thank you very much. If you have any question, please ask.